Hello everyone, I'm Andy. Today I'm going to talk about a compound, potassium nitrate. First, let's start from some general information about this compound. Potassium nitrate is a white solid and got a chemical formula KNO3. Potassium nitrate are used in toothpaste, fertilizers, matches, medicines, and fireworks. Because potassium nitrate can soothe the pain of the user, so scientists mostly add it in medicine and toothpaste. On the other hand, its flammability caused by the potassium in its compound are used in fireworks and matches. Following its chemical properties, the two figures in this slide shows the 3D molecular structure of the potassium nitrate, forming a trigonoplanar, and the powder of the potassium nitrate, which is in normal form. I will introduce more details of the structure in slide 8. As you can see from the structure, the potassium ion is then physically connecting to the nitrate. So we will now first introduce the nitrate. A nitrate consists of two elements, oxygen and nitrogen. The Lewis dot diagram of these two elements was represented in picture 3 and 4. As they combine together, these dots or valence electrons will form covalent bonds, bonds which shares one pair of electrons. The combination of oxygen and nitrogen forms nitrate. By finding a difference of electronegativity, we discover the bonds between the N and O is likely polar. The electron configuration is based on three fundamental laws, which are off-flow principle, Pauli exclusion principle, and Hund's law. The off-flow principle states the electron will take precedence to fill in the lower energy orbits. Pauli exclusion principle states an orbital can only get two opposite spins electrons. And the Hund's law states it demonstrates that one electron holds one energy of orbital and that all electrons with singly occupied orbitals have only one kind of spin state. The three principles create the basic law for constructing the electron configurations. Then we are going to talk about the electron configuration, Nobel gas configuration, and orbital diagram for K, N, and O. The components are for potassium nitrate. When marking the unshortened electron configuration, we count the total amount of electrons in the element, then follow the electron configuration chart to right. After each letter, we write the number of electrons in the orbital in the exponent form. The next form is Nobel gas configuration. By examining the periodic table, we will discover the Nobel gas have a field orbital to be stable. In the Nobel gas configuration, we put the Nobel gas with the nearest amount of electrons in brackets, then write the extra electrons in its electron orbitals. On the orbital diagram, we construct each orbital by drawing up and down arrows. In each box is two electrons. According to the order, each orbital has to fill before going in the next orbital. If the orbital is not filled, the up arrow will always be drawn before drawing the down arrows. The electron configuration of the three elements are present in Table 3 with the three kinds of presenting methods. Each molecule has a shape, according to the VSEPR theory. By counting the number of lone pairs and bonds, we can figure out the molecule's shape. The shape can later help us figure the bound angle in each molecule. After each molecule is determined by the VSEPR theory, the intermolecular forces attract other molecules. These forces can be classified into three types: London dispersion force, dipole-dipole force, and hydrogen bonding force. Then we are going to talk about the Lewis diagram, VSEPR notation, number of electron domain, molecular shape, bound angle, and intermolecular forces for nitrate. In this Lewis diagram, we can see that there are three peripheral atoms bonding with one central atom, while the bonds are all single bonds, so the VSEPR notation for a nitrate is AX3, which A shows the central atom and X shows the peripheral atoms. And there will be three bonding electron domain and no bonding electron domain. Therefore, we can also know the shape of the molecule. which is trigonal planar, because there are 3 electron domains without any lone pairs, so we don't need to minus any degrees from 120, which is the original degree. Next, the chemical and physical property of the potassium nitrate compound is interesting. Potassium nitrate is a white solid at room temperature, and is flammable for other compound which is easy to burn. Its melting point is 334 degrees Celsius, whereas the boiling point is about 400 degrees Celsius. Even NO3 is polar covalent bond, but when we contain the potassium, it becomes an ionic bond, so it got a higher melting point and higher boiling point. Potassium nitrate is soluble in water because the covalent compound nitrate is soluble in water. While analyzing the bond, we can classify it into bond energy, bond length, and bond polarity. Bond length is the distance between two bond atoms. Bond energy is the measure of the amount of energy needed to break apart 1 mole of covalent bond gases. Last but not the least, bond polarity is used to describe the sharing of electrons between atoms. Then we are going to talk about the bond length, bond energy, and the polarity of the bond, N double bond O and N single bond O. Since we are not talking about the potassium, then the combination of the compounds will be N double bond O and N single bond O. Both the single and double bond formed between nitrogen and oxygen are polar covalent bonds. The bond energy to break the double bond is 631, while the bond energy to break the single bond is 200 and 201. The length of a double bond is 106 and the bond length for a single bond is 144. One of the most common usage of potassium nitrate is the toothpaste. Because potassium nitrate decreases tooth sensitivity by entering into dental tubules and make its way to the nerves of the dental pulp. These potassium ions find their way to the pulp where they block the transmission of pain to the brain. While hot and cold would still cause the nerves to send the pain signal to the brain, the potassium ion interrupts the pain signal so that you don't feel anything. An added benefit of potassium nitrate is that it can build up in the dentate tubules. By continuing to brush with sensitively toothpaste, you can provide your dentin tubules with a large supply of potassium nitrate, which will give you lasting relief from sensitivity. These are the sources I used for this presentation. This is the end of my presentation. Thank you for your listening.